Hi everybody. Today I would like to talk about thermography and its applications in electrical maintenance. Have you ever been troubleshooting a piece of equipment and keep finding the same failed component? Maybe you've noticed this component has failed in other systems. Maybe you noticed they're all failing at the same time. If there was a way you could predict this, would you do it? I would like to discuss a type of maintenance testing that might be useful for this. It's called thermography. As a maintenance technician at a uranium enrichment facility, I have found that collecting thermographic information on critical systems can help fix problems before they become bigger problems. During our time together, I would like to talk about what thermography is, what applications it can be used for, and the safety benefits it can provide. The first topic we should go over is what thermography is. So what is thermography? Thermography is a type of non-destructive testing in which potential failures are predicted based on thermal images of equipment. Thermography is performed using an infrared imaging instrument. This instrument measures the amount of infrared radiation being emitted from an object and then converts that information into a thermal image. Thermography is generally used as part of a predictive maintenance program. A predictive maintenance program is when tests are performed on equipment periodically to gather and trend different types of information about a system to predict potential failures. As we all know, excessive heat is not a healthy trait of most electrical systems. Thermography data points can detect if a component or system has potential to fail by identifying what we call hotspots. Hotspots in systems can indicate that a component has failed or is about to fail. Thermography is performed when a system is in operation. According to a 2018 article on the website testguy.net titled Infrared Thermography for Electrical Distribution Systems, infrared scans should be performed when equipment is energizing and operating under a normal load. This means the equipment should be powered on and performing when taking thermal images. Moving to a more relevant point, we should talk about what types of applications and systems a robust thermography program can potentially benefit. The applications thermography is most commonly used for are predictive maintenance and, surprisingly enough, troubleshooting. As we discussed before, thermography can be used to identify faulty components and predict when they may cause a whole system to fail. By using temperature data to evaluate system health, a timeline can be established for scheduled outages to replace components before a system failure occurs. This can save time and money. According to a U.S. Department of Energy Operations and Maintenance Program, having an effective predictive maintenance program can save a company 30 to 40% in their maintenance budget. While normally used in predictive maintenance setting, thermography can also be used for troubleshooting. R.P. Matting, a FLIR Systems employee, FLIR is a commonly known thermal camera manufacturer. He said in a 2006 Electrical Contracting Products article that thermographic imaging instruments can identify faulty connections, fuses, circuit breakers, wiring, and other electrical components. So, in short, any issue can be identified without unscheduled outages or making physical contact to energized equipment. So if a system is having like an intermittent problem, it's most likely a loose wire. This can actually be identified using thermal imaging because when a wire is loose, when the connection isn't good, it draws a lot of resistance. Resistance draws a lot of heat, which would be visible in the thermal image. So the last thing I think we should touch on is the most valuable part of having a thermography program, which is the safety aspect. Using thermography in place of alternative methods of testing is safer for maintenance technicians. Thermal imaging is a form of testing that does not require a technician to physically contact energized equipment. In a 2013 Maintenance World article, Skrubelos and Tataki mentioned that installing an infrared inspection window in front of potentially hazardous components could allow a technician to perform a thermal scan in an even safer manner because the window provides protection from the electrical hazard by keeping the technician out of the approach boundary. So basically, the technician could walk up to the cabinet and shoot the infrared instrument at the cabinet and get its image without touching or opening any cabinet. Now, if you don't have like a one of those windows installed on your cabinets, because those can be costly, the technician would only need the appropriate personal protective equipment to open the cabinet. The technician could still be outside of the approach boundary and take the thermal images. So, scheduled outages without damage to critical equipment also take time pressures off of a technician. So, according to a report on occupational injuries from electrical shock and arc flash events from the Fire Protection Research Foundation, I found this on an NFPA site. Research indicates time pressures and supervisor demands contribute to workers taking shortcuts with safety requirements. So basically, when technicians feel like they're being rushed or in a hurry, they don't exactly, in some cases, follow all of the safety rules. This could lead to an event. Somebody could get hurt or die. So another reason that technicians may take a shortcut with safety requirements is that the equipment may be hard to reach. So ease of access is another contributing factor to taking safety shortcuts. In a 2009 article in Plant Engineering, Mike Ralph with Exelon Nuclear says using thermography for predictive maintenance allows a technician to detect abnormal heat signatures from components that can be difficult to reach due to high voltage concerns. So if a technician can't reach something, they can just shoot the infrared instrument at that and take their image from where they're at. They don't have to crawl under anything or reach their hand anywhere. So, as we close out this discussion, I would like to remind you that adding a thermography program to a maintenance program can benefit maintenance technicians and the company. Thermography is a safe and non-destructive form of testing within a maintenance program that can be used for predictive maintenance or troubleshooting. Thermography is the use of infrared imaging to determine the heat coming from a component. It can be used for predictive maintenance or troubleshooting. It is the safest method of testing that a maintenance technician can perform. I appreciate your time and hope you consider recommending that thermography be added to your current maintenance program. Thank you.